Okay, I was just getting ready before I ran out of time to talk about concavity and what is going on right here. This means concavity, second derivative always tells me about concavity. So I'm going to be able to say that this is concave up. And since there is no restrictions here on what x is, I'm going to know that it's concave up everywhere. So to finish this sketch, what I have to remember is that I was decreasing. So it's decreasing, so you can kind of see my lines right here. It's decreasing till 1. Then it was increasing until from 1 on. There was we can tell that it's going to be a minimum here. And I now know it's concave up everywhere. So I know it's going to go through those 2 points. It's decreasing, then increasing, and concave up everywhere. The next example I want to talk about just talks about graphing this and identifying the point of inflection. So what I'm going to do is just go ahead and find the point of inflection without even graphing it. So that means I am going to take the first derivative of this, which gives me 1/3 x to the negative 2/3. Now, I do just want to go ahead and find the second derivative. I want to know about the point of inflection. So I'm not going to concern myself with critical numbers or anything like that. I'm going to get negative 2/9 x to the negative 5/3. And then what I look at here is, well, my second derivative actually says I have negative 2 over 9, the cube root of x to the 5th. There is no value that's going to give me 0. There's nothing on top that it will make the top 0. But on the bottom, I notice that at x equals 0, f double prime of x does not exist. That would be a possible point of inflection. In order to know if it is a point of inflection, 1, you could graph it, or 2, we could check its concavity. So I want to know if this is actually a point of inflection before I say whether or not it exists at the inflection point. So if I test, say, 1 into my second derivative here, I will get negative over positive, so I know this is concave down. And then on this side, I'd have a negative 2 divided by negative 9 or whatever, so that would be a positive, so that would mean it was concave up. Now, if you were to graph this with your graphing calculator, that would be this part. You got to put in your original function. You would see that it looks like this. So you can see that it's concave up and concave down. The second derivative does not exist at 0 because of this vertical tangent line that occurs right there at x equals 0. So the answer to this question, does f double prime exist at the inflection point? The answer is no. We saw that using our algebra and our calculus knowledge as well as just looking at the graph.